Camera's rolling.
Alright, let's go. Hi, my name is Creed Riley, and I'm on the PSU Lunar Lion team, and I'm here in the Penn State Industrial Engineering FAME Lab. And I'm here today to talk to you about our nozzles for our own thrusters. So our nozzle is made out of a high temperature nickel alloy, and the reason that we're using this material is to avoid corrosion and the high temperatures of the exhaust gas. We want to make sure we have a metal that can withstand the temperatures and corrosion. So we're looking here. Our nozzle so far has had one operation completed, but the second operation, the interior cut, has yet to be completed. This nozzle will be completed in 2 operations, like I said, or 2 ops. And the first operation just starts off with a nickel alloy bar stock, which we will clamp down in the lathe, and then cut out the threads and interior cut with the threads. Then after that, we take the bar stock out, cut it down to approximate size, flip it around, and complete the second operation. This can be a little bit tricky because of, actually it can be very tricky because of strain hardening. And what strain hardening is as you cut away pieces of this nickel alloy, the next pass is harder and harder to cut. So this leads to deflection and breaking of the tools. One tool that deflects is our boring bar. So if anyone has ever seen a boring bar before, they'll usually see it. It's a lot bigger than this. And right at the very surface right there is our cutting edge, and it's very tiny, very fragile relative to other boring bars. And in our machining operations, we found that rather than cut the actual material of nickel due to strain hardening, the boring bar will sometimes bend and not cut it at all. This leads to a bad finish, incomplete cuts, and just a breaking of our boring bar, which costs us time, which is something we need. Also, because of the hardness of our nickel alloy, this cutting tip that I showed you tends to wear and break and chip very quickly. And again, that leads to time being consumed that we can't work. But throughout all that, we found a way to finish our first nozzle. It's right now at our testing site with a propulsion team and good hands. So we promise to make a lot more for you, and we'll see how it works out.